called me to set you up. Want me to come and wet you up. Cause you a out of town nigga like Biggie. Heard about the shit with Diddy, so I came through to vest you up. And I got a vest for 40, a vest.
Okay, so they give us that y equals ln cosine x, and they give us that the interval is from 0 to pi over 4, okay? And they want us to find the arc length, okay? So our arc length formula, again, just to remind you, this isn't the surface area one, this is arc length. So the simpler one is from a to b, and then the square root of 1 plus f prime of x squared and dx. So what they gave us here is like our f of x, right, our original function. And so we have to find the f prime of x. So we'll do f prime of x equal to, so the first derivative of ln of something is 1 over that something, so cosine x, and then times the inside function's derivative. So this would be a negative sine x, which is equal to negative tangent x, okay? Alright, so now we have to plug it into the square root, so I'll just do the square root part. So now we have 1 plus a negative tangent x squared, or I'll just write the square root part for now. So this turns into 1 plus tangent squared x, and as you might recall from trig identities, this is actually just a secant x, okay? So what we actually have in here is arc length equals, so our interval is from 0 to pi over 4, that's what they gave us, of secant x dx, okay? And as you might recall, or maybe not, I believe it was covered in a previous section when we had all of those trigonometric identities, but this is actually going to be equal to, I'll just kind of skip ahead. Well, I don't know, do you guys want to? I guess I'll show it. So basically what we have is we're going to make u equal secant x plus tangent x, okay? And this is just for explanatory purposes. Explanatory purposes, because there is a property or some formula that they give you on, I forget which page it is exactly, but we covered a section before on trigonometric identities, and it said if you have secant to the n power, and in this case n would be 1. So anyways, you'll see, but I'll just prove it for you. So the derivative is secant x tangent x plus secant squared x, and then all of this times dx. Okay, so with this, we can just reformat our integral right now to kind of look like this form. So what if we had secant x and we multiplied top and bottom by secant x plus tangent x over the same thing, secant x plus tangent x, because this is essentially, this fraction is just 1, so it's technically like it's not even there. But anyways, so this turns into, see how the top is secant squared x plus secant tangent, which is what we want our du to be. So on the next slide, I'll show you where it continues. So what we actually have is equals, and then I'll just write no bounds for this, but this is going to be like a u to the 1 du. That's what it simplifies to when we do u substitution, and that equals ln absolute value of u, and then we can plug in what, oh wow, why did I put a plus sign? That's an equal sign. Okay, so this is ln secant x plus tangent x. Okay, and then this, again, this is evaluated from 0 to pi over 4. Okay, so then we get that arc length is equal to ln, okay, so the first thing is secant pi over 4 plus tangent pi over 4, and then this is minus ln, now we're going to plug in 0, so secant 0 plus tangent 0. Okay, so tangent of 0, first of all, that's 0. And then secant 0, so that would be 1 over cosine 0, and cosine 0 is 1. So this is a 1. But as we know, ln 1 is just 0, so this whole term cancels out. We're not going to have anything here. And then for this, we have ln And secant pi over 4 is going to be a radical 2. So we just have radical 2 there. And then tangent pi over 4 is just 1, right? So this is actually our answer. I don't know if you want to make it look prettier, I don't know if that's even possible, but this is what I got for the answer. Okay?